This video introduces properties of 7 quadrilaterals and then also talks about how to use those properties to classify them in the coordinate plane. Let's get started. All right, let's first define quadrilaterals. Quadrilaterals are four-sided polygons, meaning they're closed shapes with straight sides. Okay, so if I have a closed shape with straight sides, nothing fancy, just, polygon, then one thing that's true for all quadrilaterals is that the sum of the interior angles is 360 degrees. And the reason that happens is because you can take any quadrilateral and divide it into two triangles. And by the triangle angle sum theorem, each triangle adds up, those angles add up to be 180 degrees. And so if you have two of them, then you get 360. Okay, that's even true for crazy quadrilaterals like this. If you have a shape that's like this and like this and like this and like this, where it's some kind of a concave quadrilateral, you could still cut this in half this way, bing, and you still get two triangles, each of which have angles that add up to be 360. Okay, so that's true for all quadrilaterals. And the way that this chart is designed is that all properties flow down. Okay, so the fact that the interior angles add to 360 is true for all of these 7 quadrilaterals. First, we'll talk about parallelograms. Okay, so parallelograms have all of those properties, but wait, there's more. You also have that both pairs of opposite sides are parallel. Okay, and that's true because that's the definition of a parallelogram. Okay, now the other properties, these other 4 down here, we've actually proved back in Module 1. We had a day to prove some properties about quadrilaterals using triangle congruence. Okay, and that's what these are. So we proved way back in Module 1 that the opposite sides are congruent, the same length. We proved that the opposite angles are congruent. Okay, now we also proved, or we just maybe talked about briefly, that the consecutive angles, the one right next to each other, those will form same side interior angles, and so they are supplementary. Okay, and the last idea about the diagonals is that they will bisect each other. They'll cut each other in half, so that this is the same length as this, and this is the same length as this. Okay, keep in mind as we go through this, which properties are about diagonals, because we want to verify those later on, because something interesting happens with each of the diagonals. It's a new thing that probably you've not learned before. Okay, that's about a parallelogram. Next, we'll scoot on down to rectangles. Now, all rectangles are parallelograms, but not all parallelograms are rectangles. Okay, so again, all the properties flow down, and so rectangles have all the properties of parallelograms and of quadrilaterals. Okay, but wait, there's more. We also get that all angles are right angles. It's here and here and here and here. That's actually how it's defined. And the interesting thing about the diagonals of a rectangle is that they are congruent. They're the same length, this length and this length. Actually, in construction and in building things, you have a square that will make sure that you have right angles, but you also really do measure the diagonals to make sure that they're the same, to make sure that you have a rectangle. If they're not the same, then you're off somewhere, and what you have is not a true rectangle. It actually is used. Okay? So that's a rectangle. And keep in mind, again, the properties about diagonals are important. Now, a rhombus is called a rhombus. Okay, I'm not sure why in elementary school they teach the D word, diagonal. Diamond. I call it a rhombus. That's the true mathematical name for this shape. I really don't get why they can't just teach little kids about rhombuses and call them rhombuses. I have a suspicion that this second H here is some of the reason why. I don't know why, but they don't call them rhombuses. They call them diamonds, and I have an issue with that. But whatever. Okay, this is this. I wish I would have changed this before I hit record on this video, but it is what it is. Okay, what this really is saying, because you get opposite sides being congruent. This is saying consecutive sides are congruent. What that's really saying is you have all four sides are congruent. Okay, that is the defining characteristic. That's the definition of a rhombus. All four sides are the same length. Okay, other things that you get is that, well, let me just point out this. The most important one to me about the diagonals is that they are perpendicular. Okay, that's super important. Okay, if you know the diagonals are perpendicular, okay, what you also get is you get four congruent right triangles. Okay, and that also gives you things like the angles are being bisected, they're being cut in half. Okay, those are rhombuses. Again, all rhombuses are parallelograms, but not all parallelograms are rhombuses, okay, or rhombi. Both are correct for the plural of rhombus. Okay, down here, the square, although there aren't a whole lot of characteristics that are unique to a square, but really, again, all properties flow down, and so it has all the properties of rectangles and rhombuses and parallelograms and quadrilaterals. So it has all the properties so far in this video are all true for a square, okay? And nothing else really happens with a square besides it being both a rhombus, and so all four sides are the same length, and you have perpendicular diagonals, and it being true it is a rectangle, and so all the angles are right angles, and the diagonals are the same length. Okay, so you get just all the properties of a rhombus and a rectangle and parallelogram is true for a square. Okay, let's go up to a trapezoid. Now, trapezoids have exactly one pair of parallel sides. That's the definition. Okay, and it's not mentioned here, but it should be here, is that we do have same side interior angles. So those are supplementary, and these are also same side interior angles, so they are also supplementary. Okay, and that happens because we have the parallel sides. Next, we have an isosceles trapezoid. Now, this is the shape that when you were in elementary school, there was a picture on the wall saying, this is a trapezoid. It probably was an isosceles trapezoid, okay, because there's some symmetry and they look pretty. The defining characteristic about an isosceles trapezoid is, first of all, it's a trapezoid, so I have two sides that are parallel, and the other legs are congruent. So this side here and this side here, the other two sides are the same length, okay? And just like isosceles triangles, those are called legs. Now, with an isosceles trapezoid, just like an isosceles triangle, the base angles down here are congruent, but also the ones up here are also congruent, okay? And also know that just like a trapezoid, we do have same side interior angles, and so the uncommon bases are supplementary. Now, the thing about the diagonals that you must know about an isosceles trapezoid is that they are congruent, okay? That this length here is the same as this length here, okay? Now, let me also just point out a couple of things that are not true about an isosceles trapezoid. Okay, notice that this length here is shorter than this length down here. Okay, so the diagonals do not bisect each other. Okay, also notice that this angle here looks smaller than this angle here, and so the angles are also not bisected. Okay. The one thing that happens that you have to know is the diagonals are congruent in an isosceles trapezoid. Okay, the last shape is a kite, which is actually a very simple name for a shape. It isn't anything more mathematical. It's just a kite. And the defining characteristic of a kite is that we have two disjoint pairs of consecutive sides that are congruent, meaning that I have these two sides are congruent and these two sides are congruent. They're consecutive sides that are congruent. Okay, it could look like a kite flying in the sky or something much stranger like this thing I drew earlier. If I drew it so that these are the same and these are the same, this would also be a kite. Anyway, but let's look at this picture for a kite. The thing you should know about the diagonals of a kite is that the diagonals are perpendicular. Okay. The second thing you need to know about the diagonals of a kite is that the one that divides, I did it again, the one that divides the two congruent sides, the kite is symmetric along that line. Okay, so what I get is angles that are being cut in half. I get these angles are congruent. Okay, you have symmetry left and right. Okay, and that will give you a lot of the other properties about a kite. Okay, so those are the properties of the 7 quadrilaterals. So let's go to the other side of that page. The back side has a chart that is really good at classifying all these, not all the properties, but a lot of the common properties. That fits nicely. Okay, so let's go through the first little bit, and then I will encourage you to pause the video and to try to finish this on your own. Okay, first of all, a parallelogram has opposite sides that are congruent, and they're parallel. Okay, the opposite angles are congruent, and the diagonals bisect each other. Okay, but you do not have diagonals that are congruent. That's true for a rectangle. You do not have diagonals that are perpendicular. That's true for a rhombus. You also don't have each diagonal bisecting opposite angles. That's true for a rhombus. You do not have all sides that are congruent. You also don't have all angles are right angles, but you do have consecutive angles that are supplementary. Okay, now a rectangle is also a parallelogram. So by default, you get all of these. Now, I'm not saying that the ones in here that I skipped on a rectangle are not true, but what I'm saying is all the properties of parallelogram will flow down because a rectangle and a rhombus and a square are all parallelograms. Okay. The other thing I want to point out as we're working on this is that it may not always be true, but it's partially true. Say for a trapezoid, I might say that we don't have both pairs of opposite sides that are parallel, but we do have one pair. So you can kind of clarify just part of it. Okay, so I will encourage you to pause the video and try your best to fill out this table as far as what is true. It's good for you to kind of think through and look at the properties and try to figure out what is true about each of these. So please pause the video and fill out the rest of this table as best you can. Okay, here is a table that is filled out. I'm hoping you took the time to look at this and help you understand what this table is and what it's saying. Okay, I want to point out, now that we have this filled out, the defining characteristics. So which properties are had only by that shape that I could use to define, saying, yep, this is how I tell if this shape is a parallelogram or a square or a trapezoid or whatever. Okay, and I will focus on the lens of same length. I can find length on the coordinate plane, and I can tell about parallel and perpendicular using slopes. Okay, so for a parallelogram, I can use opposite sides are parallel, congruent, or parallel. Okay, I could use some of the other ones up here at the top, but those are harder to tell with lengths and slopes. Okay, for a rectangle, you cannot use diagonals are congruent. That's also true for an isosceles trapezoid. So the one you should use is that all angles are right angles. For a rhombus, the best one to use is that all sides are congruent. Okay, you can't use the diagonals perpendicular. That's also true for a kite. Now for a square, you have to show that it's both a rectangle and a rhombus. Okay, so proving both of those is true is what you would need to do to prove that something is a square. For a trapezoid, you'd show that you have one pair of parallel sides and the other two are not parallel. For an isosceles trapezoid, you would show that you have a pair of parallel sides and that you have the other two sides being the same length. Okay? Now, unfortunately for a kite, we don't have the defining characteristic of a kite on this chart, but that defining characteristic is that you have two pairs of congruent sides. So now we'll look at plotting 4 points in the coordinate plane and determining which shape it is using these defining characteristics of the quadrilaterals. Okay, so I'm given a coordinate plane and 4 points. So I will first plot those points. So here I have quadrilateral PART. And if I asked you what shape you think it might be, it's a good place to start. Most students think it's either a rhombus or a parallelogram. Okay, and that's a good place to start. And the tools we have available to us are finding lengths and slopes. So let's start by finding the slopes, the lengths of all 4 sides. First, for PA, I'll think about this right triangle using the tool I taught you in the previous video. The length of PA is the square root of, this is 1, 2, 3, 4, 5, 6, 6 squared plus 2 squared, okay, which is 6.3. And the length of AR, let's see, you're using this right triangle, is the square root of 2 squared plus 4 squared is 4.5. Okay? And then I can find RT here, which is the square root of 6 squared plus 2 squared, using the same idea, also 6.3. And for TP, TP is the square root of 2 squared plus 4 squared, which is also 4.5. Okay, I will find the slope. Let me pause for a second and point out the fact that I already know that this is not a rhombus. Okay, because if it was a rhombus, all 4 sides would be the exact same length. So I already know that this is a parallelogram. Okay, because a defining characteristic is the opposite sides have the same length. Okay, I will still find the slopes to kind of show you how to do that. So the slope of PA, there's a rise of 2 and a run of 6. It's positive, both are positive, and so you get a slope of 1/3. Okay, for AR, I have a run of 2 and a rise of 4, so I get a slope of 2/1. Okay, notice that 1/3 and 2 are not negative reciprocals. That's what I would need to have it to be a rectangle. Okay, yeah. So for TR, I again have a run of 6 and a rise of 2, so I get a slope of 1/3. And TP, I have a rise of 4 and a run of 2, so I get a slope of 2/1. Okay. Also notice that I do have, not surprised at this, but I do have the same slope. Okay, and that should happen for a parallelogram. So the reason why this is a parallelogram is the opposite sides are congruent and parallel. Okay, now the interesting thing that happens with the diagonals of a parallelogram is that they bisect each other. Okay, that this diagonal will cut this one in half and the other way around. Okay, so I'm going to call this point right here Y, so it spells P-A-R-T-Y, party, woo woo, party. And I'll find the lengths of PY and YR and see if I get them to be the same. So here I'm looking at this little triangle right here. It's kind of hard to see, so it's so small. That horizontal distance is 2 and the vertical distance is 1. And I get the square root of 5, which is about 2.2. Okay, and then also down here it's the same triangle. YR is also the square root of 2 squared plus 1 squared, which is also 2.2. So that one is being bisected. Okay, and I have for ty the square root of, let's see here, 4 squared plus 3 squared. 4 squared is 16 plus 3 squared is 9. 16 plus 9 is 25. The square root of 25 is 5. Okay, and I can move this up here and this up here. I get, yeah, got the right one. And I have YA is also the square root of 4 squared plus 3 squared, which is 5. Okay, so I'm going to verify, I'm just noticing that the diagonals bisect each other. Okay, and we can see that from the same lengths. All right, now we could have done the exact same thing even if it wasn't a parallelogram. We could take any 4 points and find lengths and find slopes and say, yep, this has got to be a rectangle or a square or a trapezoid or whatever, right? So we have the tools here to classify any quadrilateral based on the characteristics that we looked at previously, those defining characteristics of each of the quadrilaterals. All right, this video is about classifying quadrilaterals in the coordinate plane based on their defining characteristics. Thank you for watching.